Hi kids, let's continue about redox. So we've talked about oxidation and reduction. Oxidation is the gain of oxygen, reduction is the loss of oxygen. Oxidation is the loss of electrons, reduction is the gain of electrons. Today we're going to talk about the third one, oxidation state. So oxidation is when the oxidation state goes up and reduction is when the oxidation state goes down. So what actually is oxidation state? Oxidation state is a number given to an element in a compound to determine the number of electrons it has received, lost, or shared. Okay, that seems a little bit confusing if you just look at it that way. So what I'm going to do is I'm going to teach you how to calculate oxidation states. Now the first thing you have to remember is your favorite number today is 0. Okay, now oxidation state of all elements are 0. So of course, you have to know the difference between an element and a compound. So for example, sodium here is an element, so the oxidation state is 0. But in sodium chloride, sodium is no longer an element. Sodium is an ion, so it is not 0. Magnesium is an element, oxidation state 0. Carbon is an element, hydrogen is an element, 0. Chlorine is an element, 0. Carbon, chlorine, fluorine, copper, they are all elements and the oxidation state is 0. So you must be able to differentiate that. Cu is an element, CuO is not an element. Okay, now the second thing is the oxidation state of an ion is the same as its charge. For example, sodium in sodium chloride is actually a sodium ion and the charge is positive 1. Therefore, the oxidation state of sodium in sodium chloride is positive 1. The same way, chlorine here is actually a chloride ion with a charge of negative 1. So the oxidation state of chlorine in sodium chloride is negative 1. Copper and oxygen. Copper here is Cu2+. So the oxidation state is positive 2. Oxygen here is an oxide ion. So the oxidation state is negative 2. Now, the same way where the ion has the same oxidation state as the charge, if you add up all the ions in a compound, the total oxidation state is 0. Positive 1 plus negative 1 is 0. Positive 2 plus negative 2 is 0. But what if it was something like this? K2O. So, potassium is a positive 1 charge. There's 2 of them. Oxide is a negative 2 charge. You add them together, it still becomes 0. Now, the next thing you need to remember is the oxidation state of group 1 elements in a compound is always positive 1. Group 2 elements in a compound is always positive 2. Group 3 elements in a compound is always positive 3. Now, the oxidation state of oxygen in a compound is always negative 2. For example, in H2O, oxygen is negative 2. In CuO, oxygen is negative 2. In any compound, oxygen always has the oxidation state of negative 2. The only exception is in hydrogen peroxide. In hydrogen peroxide, oxygen has an oxidation state of negative 1. This is the only exception. Okay, so the oxidation state of hydrogen in all compounds are positive 1. Okay, now oxidation state of a transition element is written in its name. For example, this is CuO and this is Cu2O. Now if you look carefully, oxidation state of oxygen is -2, so this has to be +2. Oxidation state of oxygen is -2, therefore the copper here has to be +1, because +1 times 2 plus -2 equals to 0. Therefore, this compound is called copper 2 oxide, and this compound is called copper 1 oxide. So you have to understand that oxidation state of a transition element is written in its name for the compound. So the copper 1 oxide is the oxidation state of this copper 1 and not referring to the number of coppers in the compound. Now let's look at something else. KMnO4. Can you find the oxidation state of manganese? This is a potassium ion, +1. This is an oxygen. Oxygen is -2. There are 4 oxygens. You don't know what is manganese. Let's put it as X. The total of the whole thing should be 0. So X should equal to +7. So the oxidation state of manganese is +7. So this is called potassium manganate 7. The 7 comes from the oxidation state of manganese. We'll talk more about oxidation states in our next video. See you!